For this assignment, we're going to look at the phase diagrams. And phase diagrams for our substances are going to look something like this, where you're going to usually see a Y. The Y is going to show us our three states of matter. We're going to be able to find our least amount of kinetic energy, so temperature. So the least average kinetic energy right here would be our solid. So try to draw on that. This would be our solid. The next greater amount of kinetic energy would be our liquid. And then the highest amount of kinetic energy would be our gas, okay? So that's the first thing you want to be able to look at in your phase diagram and determine where's your solid, where's your liquid, and where's your gas. The second thing you want to look at is you want to look at your pressure, because when we're talking about normal conditions, we're talking about 1 atm. And so if you take a look at this graph, notice this is in kilopascal, not atm. So 1 atm is equal to 101.3 kilopascal. These are some of your pressure conversions that you guys had worked on that will also be in this assignment. All right. Sorry, pen's not writing so well. Okay, so 1 atm is equivalent to 101.3 kilopascal. 1 atm is also equivalent to 760 torr, or millimeters of mercury. So we'll just go with torr in case you see a phase diagram with that on it. The other thing could be PSI, which you are currently doing in the gas cell labs. So 1 atm is the equivalent of 14.7 PSI. Okay? So you'll need to know this, because you'll need to be able to look at your graph and see what it's asking. And if it says ATM on the side, then you're looking for the 1. If it doesn't say ATM, then you need to know these would be the normal conditions. So we're going to go ahead and get started on our problems. So question number 1 says, the point on a phase diagram that represents the temperature and pressure at which 3 phases of a substance can coexist. So if we're looking at a phase diagram, it would be right here. It is where you see all 3 coming together. So we want to know what we would consider that point, that temperature and that pressure, where all 3 states of matter can be seen. And you did this in the dry ice lab, where we saw all 3 of them, solid, liquid, and gas, at the exact same time. Okay, is this the triple point, critical point, freezing point, boiling point, or melting point? This is your triple point. Your triple point is the temperature and pressure where all 3 are going to exist at the same time, and that's why we saw that with our dry ice, that we were able to get all 3 of them there. Because remember, carbon dioxide typically you're not going to see as a liquid. It's going to sublime from a solid to a gas, and you had to change the pressure and the temperature to get it all 3 there. Our next question. We want to know all states of matter that could exist at a temperature of 400 degrees Celsius. So we're going to take a look at our graph, and at 400 degrees Celsius, we're going to go ahead and just come up all the way up at 400 degrees Celsius. Now we're not going to assume what this is going to do, what this line's going to do, okay, because we're not sure. So we're just going to come straight up for what we can see on the graph. So we see that we're passing through 2 states of matter, this one and this one. So I want to know what states of matter would exist at 400 degrees Celsius, and there are 2 of them. Our next question, bromine liquid at 70 kilopascal, okay, 70 kilopascal. We want to know what it will do when the temperature is decreased to negative 15 degrees Celsius. So let's come down here and look. We've got kilopascals on the side, okay, and so bromine liquid. That means the bromine's going to be here. So at 70 kilopascal, coming over right about here, we're at least -8, -7, somewhere in there degrees Celsius. We want to know what would happen if we come back to -15. So we're coming from our liquid to our solid at -15. Which of the following changes of state would occur? Would that be subliming, so sublimation, freezing, or it will freeze, melting, condensation, or vaporization? So once again, if bromine is a liquid at 70 kilopascal, when the temperature is decreased to -15 degrees Celsius, which of these changes of states would occur? Sublimes, freezes, melts, condenses, or vaporizes? That last question you need to take a look at. we would notice that the substance would freeze at the 70 kilopascal. The next graph that you have like this, I'm going to give you a little less direction and start letting you do a little bit more of that on your own. What is the normal boiling point of bromine? So we take a look, and we have kilopascal on the side, not ATM. So remember what I told you at the very beginning of the video. 1 ATM is 101.3 kilopascal. You can even see this dashed line is going through that. Okay, the dashed line is going through what would be about 101.3 kilopascal. I want to know what the normal boiling point of bromine is. So we are looking on this phase diagram where the liquid would be going to a gas. Would that be -8 degrees Celsius, 58 degrees Celsius, 30 degrees Celsius, or bromine will only sublime at normal temperature and pressure? Which of the following best explains one way that the substance can change from the gaseous phase to the liquid phase? Gaseous phase to liquid phase. So we're going to take a look at our phase diagram and know that we would have gas here and know that liquid would be here. We want to know how we could do that. So before I look at the choices, let's ask ourselves, how can I get from a gas to liquid? Well, I could come back this way, which would change something down here. Or I can go up this way. Okay? Your choices: increase the temperature and increase the pressure, increase the temperature, increase the pressure, or you cannot do that. There is no way on here to go from a gas to a liquid. Those are your choices. The image shows the phase diagram for bromine, and if standard room temp is accepted to be about 21 degrees Celsius, okay, what state of matter would bromine be found at standard temperature and pressure? What state of matter would we expect to find bromine if we recognize 21 degrees Celsius, so right about here, as standard temperature? Would that be a plasma, would it be a gas, a solid, or a liquid? If you had a quantity of this substance at a pressure of 0.75 atm, so let's find our 0.75 atm, and a temperature of 0 degrees, so we're hanging out right here. This is where we're at. What state of matter would this be? All right. We want to lower that pressure to 0.25 atm. So we're keeping the temperature, we're keeping the average kinetic energy the same, but we're going to lower our pressure. So we started at this state of matter, we're coming here. What phase transition or transitions would occur? Would that be melting, deposition, freezing, condensation, sublimation, or vaporization? Just a few questions left here. Which change of state could not occur at 200 degrees Celsius for compound X? So we're going to look at 200 degrees Celsius, okay, and see all the way up that we only have the option of these two states of matter at 200 degrees Celsius. So which change of state could not happen? Okay, no matter what we did to the pressure, we would not be able to do. Okay, deposition, boiling, sublimation, or every one of your changes of states can occur at this temp as long as the pressure is just changed appropriately. So we can melt, we can freeze, we can sublime, deposition, we can go through boiling and condensation. That's what this last question means. It's every one of those changes of state can happen. Or you're saying one of these cannot happen. Okay. What is the normal boiling point of the substance? So you want to look at what your pressure's in and ask yourself what the normal pressure would be. And we want to look and see at what temperature would we be going from a liquid to a gas. Bromine vapor at 15 degrees Celsius. Okay, so 15 degrees Celsius, bromine vapor. Vapor means gas, so we're hanging down here. Okay, so at 15 degrees Celsius, we're in the gas. We want to know what's going to happen when the pressure is raised to 50 kilopascal. So what would bromine vapor do if we raise it up to 50 kilopascal? So it means if we're in the vapor form, we're here. Which one of the following would take place if we went to 50 kilopascal? Would that be condenses, melts, boils, freezes, or sublimes? And your last question, if I had a quantity of this substance at a pressure of 1.25 atm and 800 degrees Celsius, so 800 degrees Celsius, 1.25 atm, right about here, what phase change would occur if I decreased the temperature to negative 100 degrees Celsius? And at what temperature would they occur? So we're staying at the 1.25 atm. We're starting here. We're coming back. So we're going through a phase change there. Coming back. Going through a phase change here. All the way to negative 100. All right. We want to know what phase changes would take place from here all the way back here, and at what temperature would those phase changes happen.